So algebra is all about cracking the code and working out what different numbers and what different things stand for. So here's an example. I could have a question which was x plus 3 equals 7. And one of the key things is knowing that your equal sign is really the same as a balance. So let me redraw that same problem, but let's make it look like a bit of a balance. So on this side of my scales, I have got x plus 3, and on this side of my scales, I've got 7. So I'm always trying to get x on its own. So if I look at this side, what's stopping x being on its own is that we've got an additional 3. So over at the side, I'm going to record that I'm going to take 3 away. And I'm going to take 3 away from both sides. So if I take 3 away from this side, I'm just left with x. And if I take 3 away from this side, I'm left with 4. I can then put that 4 back into my original equation and see if it works. 4 plus 3 equals 7. And I know I'm right. So let's have a look at another example. So this time my equation is x plus 11 equals 20. And again for this one, let's draw it on a set of scales. So here's my balance. Here's one side, and on that side I have got x plus 11, and on the other side that's going to balance with 20. And again, the first thing I'm going to say is what's stopping the x from being by itself, and it's the fact that we have got this plus 11. So the first thing I'm going to do over at the side is I'm going to take 11 away from both sides. So if I take 11 away from this side, I'm going to be left with just x, and if I take 11 away from this side, I'm going to be left with 9. I'm then going to put that back into my original equation, so I'm going to take my 9 and say 9 plus 11 equals 20, and therefore I know I'm right. So it's important to remember that x can be any number. But how would it look and how would we set it out if we weren't drawing the balance scales? So I'm going to start with x plus 45, and this time it's going to equal 76. And when I'm writing my equations, one thing I am going to do is keep all of my equal signs in a row. But looking at this one to begin with, it's the 45 that's getting in the way. So over at the side, I'm going to record that I'm going to take 45 away. And I'm going to do it to one side, I have to do it to both. So on the left-hand side, I'm left with x, and that equals, now on this side, I'm actually doing 76 take away 45. And 76 take away 45 means that x equals 31. I'm going to take my 31, put it back into my equation. 31 plus 45 equals 76. I'm always going to do that check. Sometimes we can't solve the equation in one step, like in this example. So 7 minus x equals 4. In this example, I have got a minus x, and when we're dealing in minus numbers, that gets confusing. So the first thing I'm going to do is to remove the minus x, and the way I do that is I'm going to start by adding an x to both sides. So over on my left-hand side, I'm starting with 7 minus x, I'm going to add an x to that, so on that side I'm going to be left with just 7. I'm going to keep my equal signs in a row, and on the other side I've got to add an x, so it's going to be 4 plus x. Then I'm back to where I used to be, because I'm back with a positive number, but what I need to make sure is that I'm getting rid of the 4, because the 4 is getting in the way, so I'm going to take 4 away from both sides. It doesn't matter which side I do first. So on this side, if I take a 4 away from that, I'm going to be left with x. And on the left-hand side, if I take 4 away from 7, I'll be left with 3. I'm then going to put that number back into my equation. 7 take away 3 equals 4. And I know that I'm correct. So let's do another example that uses minus x. So 11 minus x equals 5. Because I've got that minus x then, I want to get rid of it. The first thing I'm going to do is add an x to both sides. So 11 minus x, add x, leaves me with 11. And on the other side, I've got to add an x, so it's 5 plus x. I want the x on its own, so it's the 5 that's getting in the way. I'm going to take 5 away from both sides. So I'm going to start this time over on the right. So if I take 5 away from 5 plus x, I'm going to be left with just x. And on the left-hand side, 11, take away the 5, leaves me with 6. So let's put it back into the equation and check it works. So if x is 6, 11, take away 6 equals 5. And then I know I'm right.